This battery is a 1.5 volt AA, and the voltage on this does not increase or decrease until you use it. If you use it, it decreases, but it's not going to increase. Yellow is the porous barrier. So the question is, why do you need the porous barrier? Raise your hand.
So you don't electrocute yourself?
So all the reaction doesn't happen at once, right? If you didn't have a barrier, you wouldn't be able to control the reaction rate, which is the first human experience with electricity. Anybody know? Made a spark? Raise your hand. Can it?
Made a spark.
No. Well, it made a spark. What do you mean it made a spark? Where did it make a spark? Electricity. Not talking fire, we're talking electricity. If you look where it says matter becomes electric, was it lightning? Raise your hand. Was it lightning? The battery. Does the voltage increase or decrease on the battery? Raise your hand. Does the voltage increase or decrease, Emma? You don't know? Ethan? Increases? Rachel? Decreases. It doesn't either. It stays the same. Ron, Noah?
Yes.
What colors could he not see?
Red.
Green.
Raise your hand, Noah. Okay. What colors could he not see?
Blue.
No.
Red.
Raise your hand. Anybody else? Rachel?
Red and green.
You could not see red and green. Very good. Now this would that be a problem in the lab? If you're colorblind, is that an issue like in science? Yes, it is. If you looked at one of the first group of scientists, they had to use like manuscripts. They wrote everything down. They colored it, what they could see. And in a lab, right? If you're in a lab and you're trying to repeat experiments, and there's a color you're looking for, it's going to be very difficult to see that color. So it would have been I don't know if I would have let him into the lab knowing he was colorblind. It could be dangerous. Did he tell everybody he was colorblind? Probably not. He actually researched his own illness and determined it was genetic.
Well, like, if you was colorblind for a specific color, wouldn't it come like...
Scientists follow the same line of thought they've been using all along. Substances are made of elements, and elements are made of atoms. And what they ask are atoms.
Backtracking, we got 16 as a sophomore to 5th as 11-year-old. So he attained the 5th grade level of education. Hydrogen, and I divide it by itself and make it 1. And I do the same thing with all the other elements. Then gold is 191 parts of hydrogen. Does this make sense? Are you following to that? Are you relating to that? Do you understand? Raise your hand if you don't understand that. Okay, let's try to explain. I'm just making these numbers up on this balance. If they're using lead, let's say as the weight, and you had 3.3 grams of lead, and you had the same volume of hydrogen and oxygen, and it measured out to be 3.3 grams of hydrogen, and 32 grams of lead was equivalent to 32 grams of oxygen. Now what he did next, he took the 3.3 and divided by itself. And what do you get when you divide 3.3 by 3.3? 1. So then he took the 32 grams of O2 and he divided it by hydrogen. Now his numbers basically became whole numbers. The point is that sulfur would be 10 parts of hydrogen. We do the same thing today with the proton. Today, I showed you this table here. What's significant about Dalton was the first person to put the elements in a table. Now this isn't a periodic table, it's just a table, like in the book you see tables, and he's just listing them, right, in a particular order. What order is he listing them? Yeah, based on their weights, right? And so what he did, if you have a reaction, right, and you have a balance, and you're comparing it to some weight here and some weight here. Let's say when you did hydrogen, the weight over here measured out around 3.3 grams. And so he's saying, okay, we have our balance here, so hydrogen must be 3.3 grams, right? And then he looks at, let's say, oxygen. He does the same thing, and oxygen is found out to be like, let's say, 32 grams, so 32 grams of O2. So then what he does, he takes 3.3 grams H2 and he divides it by itself. And he gets 1 gram H2, right? And he does the same thing with the O2, so he takes the 32 grams. These numbers are just made up. We don't really know what numbers he had because he rounded it to 1, obviously, divided by itself. And then you divide that by 3.3, and you would get a comparison to hydrogen. Okay, so Volta is considered to have invented the battery in 1800. It says, with the invention of the electric battery by Volta in 1800, one could run a steady stream of negative charge, a current. I have read that the Egyptians are thought to have experimented with batteries. Because if you go inside the pyramids a certain distance, it's just not healthy to carry a flame or a torch because you're going to start to like burn up all the oxygen and you could die. So the thinking is that they were the first to work with metal and chemicals like acids to get a current and then have light. Now we don't know what they did, but if you read that they might have been working with, you know, metals and chemicals, then you would probably want to investigate a little bit more to see if you could replicate that or do something similar. So I'm not saying that Volta was the first person, but I've read that there were other people before him, namely the Egyptians and the pyramids, that they might have worked with batteries. The battery has got a paste of chemicals, it's got a porous barrier, it's got a metal, maybe zinc, it's got a positive terminal, carbon, and what does the porous barrier prevent?
Fire.
It prevents the paste from reacting all the time with the metal. You've got to have some way of keeping them separate. Now what's going through the porous barrier to get to the metal? Might know? What's going through the porous barrier to get to the metal? The anions. So there are anions that are going to move through. You're probably thinking, well, how does that happen? Well, rust happens. If you're not familiar with it, it can get through the atmosphere. Ions can travel through porous barriers. Anions can. Rust occurs. Are you familiar with that? Rust? Right? So basically what happens is that this terminal will rust. Now, will it rust quicker in a hotter environment or a colder environment? A warmer environment. If you want to keep your batteries for a long period of time, you should store them in like a refrigerator or a freezer. Some people store the batteries in freezers. Make sense? Type of carbon would be the fullerenes, and they're associated with carbon nanotubes. And carbon nanotubes would be associated with what? Anybody ever heard of carbon nanotubes? Where would you see carbon nanotubes? Anybody heard of like carbon fiber bicycle?
Oh yeah.
Carbon fiber automobiles? Yeah, that's going to be associated with the nanotubes. The buckyball is not. You're going to see the buckyball in maybe like paints because it helps. That's, from what I've read, that's the most stable form of carbon. It has like the structure of diamond in a ball, a buckyball up there. Booklet has pictures when you're trying to assemble something, and this is going to be true with the collider. They're going to have pictures of things breaking apart, and then they try to, okay, let's see if we can do this reverse, and then make a new substance. A lot is being invested right now in nanotechnology. What's nanotechnology?
Very small technology.
What are they trying to do?
Make very small things.
Well, if you look at oxygen, right?
Cells.
Oxygen has something called an allotrope. And what does that mean? Have you ever heard of an allotrope? Where you have oxygen by itself, which is a radical, and you have O2, which is what you breathe, and then you have O3, which is ozone. So O2 and O3 are called allotropes, in that they're both made of oxygen, but they're very different. So the goal in nanotechnology is to make things like this. This is called a buckyball, right? And it's basically carbon in an arrangement that is new to us, because prior to the buckyball, all we had was graphite, what else? Diamond, and what else? And there was three of them, graphite, diamond, and the coal. Right, Dalton was born colorblind. His brother also was colorblind, and he could not see which colors. Raise your hand. Adam.
Green and red.
Right, he couldn't see green or red. And the term for that today that describes this genetic deformity is called daltism. So if you were born with this genetic deformity, they will say you have a genetic deformity called daltism. Bell work today on John Dalton. Name the highest level of education that John Dalton completed. Hannah?
Is it college?
College? No, that's not correct. Anybody else? Michaela?
Secondary school?
Secondary school? No. Carol?
Is it just primary school then?
Primary school, like what grade?
Elementary.
Fifth grade?
Yeah.
Yeah, he completed fifth grade.
Okay.
So he had a fifth grade education. Yes. Once he completed fifth grade, when did he start teaching?
They let him teach English after going to school for 5
He
years.
was a fifth grader. When did he start teaching English?
7 years
Huh? Do you see an example of a DC motor? How many magnets do you see in that picture? No, yeah, there are two magnets. You have your north and your south pole magnets. Now, if I could draw a line, I would show you that the electrons are going to flow in this direction, north to south, or positive to negative. This is negative. They would flow in this direction, because electrons always flow from the negative to the positive. Make sense? So you've got, the electrons are going in this direction. Everybody clear? That's your DC motor. This battery is a 1.5 volt AA, and the voltage on this does not increase or decrease until you use it. If you use it, it decreases, but it's not going to increase. Our first experience, our first exposure with electricity. Raise your hand.
Key.
No. What was our first exposure to electricity?
Light
Yeah.
bulb. Like.
No. No.
Electricity.
What was our first exposure to it? When did we experience electricity first? No. We just read about it. I was just seeing if y'all were paying attention to what you read. Right here. What is this? What is this talking about here? It says matter becomes electric. What are they talking about there?
Adam. When matter.
Raise your hand.
Friction.
No.
Adam.
No. No. No.
Never.
Raise your hand.
Opposite.
No.
Charges.
What associated? No. Can you read that?
No.
What? Matter.
I got you, Nick. Without the barrier, like Ariel was saying, without the barrier, the reaction is going to take place all at once. There would not be the ability to store energy here. So the porous barrier, this yellow, allows us to have energy when we want it. That's what a battery allows you to do, is to turn the light on when you want to, right? Example of an alternating current motor. In an alternating current motor, you've got more than one magnet going in a different direction. So you can see how the direction here of the electrons is curved. See how it's curved there? There's a curve. So in a direct current motor, you don't have that. It's just spinning, and there's a north and a south pole. The electrons are just, the waves are going to be going in one direction. You see out here you have different wavelengths? That's what an alternating current motor does. It gives you a different alternating current. Right, see that? In a direct current, you don't have that. It's just one direct current. The problem with the direct current is that it tends to heat up more. So Edison's model, basically the electricity didn't travel as far because it started to heat up in the wire. You had to send out more and the wire got hot. And that's a fire hazard. You can't have fire hazards. That's not good. People don't want their houses burning down. Make sense? So direct current, you see a direct current typically in your oven. Your oven basically changes the alternating current to a direct current. So the direct current, this alternating current here allows the current to be changed as it's being generated. And this allows the electricity to be transported a greater distance. Make sense? All right. Any questions on that? So there was a debate or a challenge between two inventors, Tesla and Edison, concerning electrons and transporting them from one location to the next. What was Edison's idea? What did he want to do? How did he want to transfer electrons from one place to the next? You might know. He chose the DC current model. He was trying to transport electrons by direct current. And what did Tesla want to do? What was his thinking? AC. So his thinking was AC was a better method of transporting electrons from one place to the next. Being a motor, one of the things you have to be careful about is how you place the magnets. Because if you place them to where the positives are all lined up, this is going to create a repulsion, right? And if you create repulsions enough, you can actually create channels in the magnet where it loses its magnetism. So it's not easy to come up with the right organization of the magnets. This took a little bit of effort to do. What's the most effective way to do this? Those are patented, copyrighted type things. repel is with one L.